Good morning, dear students. I am Dr. Srinivas Patini, Professor of Chemistry in St. Peter's Engineering College. So today, I am going to explain the potentiometric titration. This is very useful in the lab. So we have 2-3 experiments based on this potentiometric titrations. So this is very important. So both the cases, this topic is useful in the lab as well as the theory exam. Okay, so what is the topic? The potentiometric titration. So this is the topic I am going to explain. So till now we have discussed the electrochemical series. The last video we have discussed the electrochemical series, and before that we have seen some electrodes like caramel electrode, glass electrode, quinidone electrode and hydrogen electrode, that is a reference electrode. Okay, we have seen all these things. So I remember all these electrodes. Okay, these electrodes are very useful for the study of the potentiometric titrations. That electrodes are very useful in this topic. The previous topics are what? That electrochemical series, electrodes, especially glass electrode, caramel electrode, hydrogen electrode. These are very useful in the potentiometric titrations. In the unit first, we did some titrations. Have you any idea? Some reactions. That hot water estimation. We have used the EBT indicator. EBT indicator. EBT, electron black tea indicator. For the estimation of what? For the estimation of the hardness of water. By which method? Complexometric method. So there we have taken, what is that? 1 burette we have taken. Okay? 1 burette. One beaker. We have taken 1 beaker. How titrated, these are the values. Burette mean, for example, 1 ml, 2 ml, 3 ml, 4 ml, like that, 50 ml, and this is the solution. So we have used this is the reducing one. We can use that. Regulator, we can say regulator. This is the regulator. This is the burette, and this is the beaker. So we have seen in the first unit. So simple, we have taken solution in this. For example, sodium hydroxide solution, whatever the solution we have taken in this, and dropwise we have to fill like this, and it is color used in the indicator, some phenolphthalein or EBT indicator, or some are other indicators. What? Phenolphthalein, others, not in this one, other titration, phenolphthalein indicator, and many indicator, dichromatic indicator, like that indicators are used. This is the simple titrations. But in the case of potentiometric titration, no indicator is used in potentiometric titration. No indicator. So how? Already we studied the indicators, mean electrodes. The electrodes are useful. The electrode, if you use the electrodes, there is no need to adding of the EBT, phenolphthalein, methyl orange, dichromate. There is no need to add in this beaker before going to titrate. So in potentiometric titration is one in which the endpoint is detected by measuring changes in the potential suitable electrode during the reaction. So in this case, we don't add any indicator in this. So what I will do, we have to use the electrodes. This is the electrode. So electrode, we have to use electrode. So electrodes, what type of electrodes? I will tell you, different reactions having the different. So what happened in this titration? First one is the indicator is, no indicator is used. Only the titration in one in which the indicator, the endpoint detected by measuring the changes, detected by only electrodes, potential suitable electrode during the titration. The electrode whose potential value just as yesterday before, potential means electrode potential values. The electrode whose potential varies during the reactions. Mean drop wise we have to add to this one. So and which depend upon the concentration of ionic species. The indicator is called the electrode indicator. The indicator electrode or indicator. So we can say indicator electrodes. So after drop by drop, after addition, so always depend upon the concentration of the ionic species. What is the concentration? 1 molar or 2 molar, 3 molar concentration. The species is called the what? Indicator electrode. You have to remember that indicator electrode. The endpoint of the reaction is indicated by sharp change. We know that in methyl orange or EBT, suddenly will change, color change will take place. The endpoint of the reaction is indicated by a sharp change in the potential of the system. The titrant is added. This is the titrant. In period, what is that taken? Titrant. The titrant is added in a small amount. Titrant is added a small amount, little bit, 1 ml, like 1 drop by drop. The titrant is added in a small amount and change in EMF. That EMF. So that EMF will create. So we have to change takes place. EMF values. EMF values mean electrode potential. Yesterday we have seen standard electrode potential values. So we have to record that values in the notebook. The titrant is added in a small amount and change in EMF. So every 1 ml, 1 ml, how much EMF will come? Then 2 ml, how much? Like that we have to record. EMF record. After each addition, every addition, 1 ml or 0.5 ml, 2 ml like that. So the approaching equivalence, equivalence will approaches. Equivalence. So equivalence is important. The approaching equivalence point is indicated by rapid change of EMF. The change is some very rapid change. Rapid change takes place. What is the equivalence? The approaching to equivalence, the rapid change of electrode potential. At this stage, the addition of titrant is regulated. We have to control. We have to regulate it. And the titration is continued after. Here we have to regulate. So at a certain point, the equivalence reach the titration. Then, so don't stop it and continue even after the equivalence point. The endpoint is the point which corresponds to maximum slope in the plot. The endpoint is what? The endpoint is the plot which corresponds maximum slope in plot. Maximum slope in plot of electrode EMF value, electromotive force. So mean the plot versus volume of the titrant. So wait, this is the value, how much, and versus this one, EMF, electrode potential. So we can take the plot. How can you do the plot will come? For example, the plot will come EMF value, EMF or EMF value and value. So like that, these values will come. So the volume of titrant. So what we are taking in burette, that is the value 1 ml, 2 ml, 3 ml like that. And EMF reduction potential, how much? So indicator, this one will come. In indicator, the potentiometer will give that one. So this is the indicator titrant we are taking in a burette, and in the solution beaker we have to take in, that is the electrode indicator we had added here. So this is connected to the potentiometer. So in the potentiometer we know how much EMF will come, the EMF value. No need to calculate, that directly will come. Just you have to draw the graph. So I will explain you, this is about the general potentiometric titration. I will tell you the example very clearly. So potentiometric titrations are subdivided into in terms of chemical reactions. Different types of chemical reactions are there. Many reactions in the chemistry. So depend upon the some of the reactions I will tell you though, that what are that chemical reactions involved. They are the acid-base titration, redox titration, precipitate titration. Redox reactions we know, acid-base, strong acid, strong versus HCl. Already in intermediate we know that acid-base titration using a phenolphthalein indicator. So same titration we have to use, but don't use the phenolphthalein, methyl orange or dichromate. Just you are use here what? Indicators, the electrodes, glass electrode, caramel electrode. Just one example I will tell you. So like that we have to explain. One type I will explain you clearly. Then you have to do same way in all that one. Okay. See, so they are subdivided acid-base titrations. One is the acid-base titration, and second one is the redox titration. And third one is the precipitate titration. And fourth one is the determination of pH by EMF method. Determination of pH by electromotive force, that is standard electrode potential, by, we can say, by EMF method. In this I will explain you very clear acid-base titrant, because we have in the lab also. So please listen carefully this one. Then automatically similar redox reaction, precipitation, like that, everything is there. Okay, clearly I will explain you. So first, acid-base titration. So best example is, what is the best example? Here, acid-base titration. So best example is the HCl versus NaOH. It is a well-known example. We know already in intermediate. So the acid-base titration. The HCl is taken in a beaker. Here HCl, simple. HCl is taken in a beaker, and the indicator electrode, one electrode. This is the electrode, electrode. What electrode we have to use? The glass electrode we use definitely, because HCl versus we have to use the glass electrode. Glass electrode. So already we studied the glass electrode. So glass electrode is placed in it, in a beaker. Okay. It is then connected to reference electrode. We have said one reference electrode. So calomel electrode we have to take. So connected to a reference electrode. One more reference electrode. Reference electrode. So reference electrode we have to take the calomel electrode. Well, electrode. We have to connect it this one. Connect this one. One glass electrode and one reference electrode. So first of all, what HCl is taken in a beaker, in a beaker, and this glass electrode placed in the beaker, and it is connected to standard electrode, that is a calomel electrode, to form galvanic cell. To form a galvanic cell. Galvanic cell. Galvanic cell. The cell is then connected to the potentiometer. Now the potentiometer. So this one you have to connect the potentiometer, digital potentiometer. This is potentiometer in the lab. So you can see in the lab, many are there. We have in our lab many potentiometers are there. We can see and switch it up. The digital will come. So no need to here whenever titration, they are either increasing order or decreasing order. Digital will come. Digital numbers. The cell is then connected to the what? That first of all, the glass electrode are placed in beaker, then connected to reference, then connected to the potentiometer. That is its E cell is determined. Then automatically the E cell determination takes place. Okay. The cell when it is titrated against the standard NaOH, because here we have taken HCl, so in this beaker, so we have to take the NaOH solution. HCl versus NaOH. In a burette, we have to use the NaOH solution. NaOH solution. So which is the EMF is going on decreasing H plus ion concentration. Now, so what happened? So what is the reaction takes place? Generally acid base, general reaction in our mind. When acid react with the base, what will form? Salt will form. That is general equation. HCl react with the NaOH. What will form? NaCl and water. This is the general equation. HCl react with the sodium hydroxide. Acid react with the base to form the salt. Salt is the sodium chloride and water. So what happened here? The EMF is going on decreasing H plus ion concentration. So what happened here? So the H plus are decreasing in the acid. What happened? So here in this H plus and Cl minus are there. So slowly H is decreasing. H is decreasing. NaOH is coming slowly. So what happened? First mole NaOH. So Na react with salt will form here. Then what happened? Sodium chloride. H plus is there. The H plus and OH, water, it get diluted. So water is there in this beaker. NaCl is there. And first 1 ml, for example. And HCl also there. So slowly in the first ml it is replaced. Mean this one slowly decreasing H plus ions. slowly decreasing, decreasing. After some equivalence point, so there is no H plus ions, there is no HCl. What is there completely? NaOH, NaCl, H2O, NaCl. Then after equivalence point, so if we add, it will become completely base NaOH. After endpoint, after equivalence, then you have to add continuously, then directly NaOH. There is no HCl. So this is the titration. What is that? Just once again listen. Please listen. HCl versus NaOH. In this HCl, we have to take in a beaker, and the NaOH taken in the burette. In the beaker, electrode is added, placed it, and it is connected to the reference electrode, and both are connected to the potentiometer. And what happened with the titration? This is the Hc plus ion concentration decreasing slowly. So what happened? HCl react with NaOH to form this NaCl and water molecule. At the end point, EMF is suddenly decreased here. At the end point, suddenly decreased. After the end point, there is no noticeable change in the potential because NaOH is added direct. There is no directly after the equivalence point, after the end point. So there is no change. So NaOH same point will come. There is no noticeable change in the potential when the EMF is plotted against the value of NaOH. So we can see. So how can you draw the graph? For example, so decreasing mean, I will write that. So what happened? Decreasing the H plus ion concentration. So the graph is like here, this is the graph. So standard electropotential value. Here we can write the standard electropotential value. And the what sodium chloride formation or takes place here. Here sodium chloride mean volume of NaOH. You can take a volume of NaOH mean sodium chloride formation. Volume of NaOH. So here every 1 ml. So what happened? That the formation of NaCl here. So what happened here? Like this. Like this. Mean a curved shape will come here. So mean slowly decreasing the H plus ion concentration. Mean potential values are slowly decreasing like that. Here slowly decreasing. So one more. So the plot against delta E by V, we can plot delta E by delta V. So the plot will come like this. This is the maximum. So here, in this case, the value of NaCl is from NaOH. The value of NaOH is added here. The formation of NaCl same. So maximum we can see that one. So the endpoint is the point where the slope of the curve is maximum. Where the curve is maximum curve. Where is the slope? For example, this one. Maximum curve. Endpoint is the point where the slope of the curve is maximum. A more sensitive and satisfactory method of detecting the endpoint will be graph delta E by delta V, mean electrode potential versus volume against the volume of NaOH. So this is about the standard acid-base titration. So draw the diagram and take the Cl and titrate against the sodium value, and H plus ions are slowly decreasing, formation of the salt, and that decreasing this graph and maximum value this one. So the end point, the slope of the curve is maximum. Okay, this is one. And about the redox titration. So in the redox titration, everything is same. I will write the one equations. Okay, so equations I will write that redox titration. So this is for the HCl versus. Okay, so in the case of redox titration, example ferrous sulfate versus potassium dichromate, FeSO4 versus potassium dichromate, K2Cr2O7, potassium dichromate. Here ferrous to form the ferric, increasing the ferric ions, increasing the ferric ion, Fe plus 2 increases the Fe plus 3. Here the H plus ions are decreasing in HCl versus titration. In this redox titration, what happened? Decreasing the mean Fe plus 3, increasing the ferric ions, increasing the ferric ions, ferrous and ferric ions. So this is in the example, and everything is same, the graph will form. Okay. And next the precipitation reaction. We know precipitation. Precipitation means gelatinous PPT, white PPT, that is a precipitant. So this is the best example, silver nitrate versus the sodium chloride. So precipitation reaction where the silver nitrate versus sodium chloride we have to take. Sodium chloride. So the best example this one. And what is the reaction here? Silver nitrate plus NaCl. So what will silver chloride is formed? Silver chloride and plus NaNO3. NaNO3. So silver ion concentration is decreased here. Silver nitrogen. Here the concentration of silver ion concentration decreases. Like H plus ions. Silver ion concentration is decreases. So we have to write this much is enough for studying about the potentiometric titration. So definition and general example and the acid base titration, redox titration, precipitation traction and names and determination of pH of EMF the method, and completely you have to write. This is the lab method. So we are going to do this experiment. So anyway, that is we have to remember. So titration, one diagram, one graph. That is main point is in this HCl versus H plus ions decreasing the H plus. This is very important. H plus ions. In redox ions, the ferric ions are increasing. Ferric ions. This is very important. And in the case of precipitations, silver ions are decreasing. So decreasing, increasing the ferric. These 3 points you have to remember. So this is sufficient for getting good marks. Okay. So this is about the potentiometric titrations. In the next class we are going to start the batteries. Okay. Thank you.